Okay, here's question 2 from the test from Friday, May 8th. We are given the graph of g, okay, and the line tangent to the graph of g at x equals 0, and f is a differentiable function where f is the square root of 10 minus g of x. Okay, so first question, equation of the line tangent to f at x equals 0. So f is square root of 10 minus g of x, or 10 minus g of x to the 1/2 power. So we need f prime because we need the slope. So using the chain rule, 1/2 of 10 minus g of x to the negative 1/2 times the derivative of 10 minus g of x. That's going to be negative g prime of x. A lot of people left off that negative. So now to find f prime of 0, it's going to be negative 1/2 times 10 minus g of 0 to the negative 1/2 times g prime of 0. G of 0, we go to our graph of g, and g of 0 is equal to 1. Remember, this is the graph of g. So g of 0 is equal to 1. So we have negative 1 over 2 square root of 10 minus 1 times g prime of 0. We need to know what's the slope of this g graph at x equals 0. Well, that's why they gave us the tangent line there. We just need the slope of the tangent line, and we look and we see the slope is up 1 over 2. So it's a slope of 1/2. So we have negative 1 over 2 square root of 9, which is 3, times 1/2 gives us negative 1/12 is our f prime of 0. Then f of 0, just sub g of 0 into 10 minus g of x, and we get square root of 10 minus 1. Square root of 9 is 3, so our tangent line is y minus 3 is negative 1/12 of x minus 0, or just negative 1/12 of x. Okay, so now here comes what I think was probably the hardest part of this whole test. Let g of 2 equal a. Evaluate integral from 0 to 2 of f of x times g prime of x dx. So if we look at that, in this form, it's very confusing. When you sub in what f of x is, maybe it's not so confusing when we see f of x is a square root of 10 minus g of x, and then times g prime of x. This is just a basic u sub. We're undoing a chain rule. So if u is 10 minus g of x, du is negative g prime of x dx. So we sub in, and we get negative u to the 1/2 du. Okay? Integrate negative u to the 1/2 du gives us negative 2/3 u to the 3/2, just doing simple integration. And now we sub our u back in, and there we go. We're going from 0 to 2. So now we sub in our values, negative 2/3 of 10 minus g of 2 to the 3/2 minus 10 minus g of 0 to the 3/2. So negative 2/3 of 10 minus a to the 3/2 minus 10 minus 1 to the 3/2. And you could actually stop right there. If you keep going, you get negative 2/3 of 10 minus a to the 3/2 minus 27, which will give you negative 2/3 of 10 minus a to the 3/2 plus 18 if you multiply it all out. But remember, you can stop right here and get full credit on the AP exam. Okay, so that part, I think the key was right here, rewriting the f of x as square root of 10 minus g of x. Okay, part C, here we go again. Guys, you got to get used to this. If you see a limit question as one of the parts on your test, it's probably going to wind up being a L'Hopital's question. So if we evaluate the limit as x goes to 0 of f of x minus 3 over g of x minus e to the 2x. So that's f of 0 minus 3 over g of 0 minus e of 0. F of 0, sub 0 in, I mean, we have it back up there in part A, is 3, so we get 3 minus 3. G of 0 is right on the graph, is 1, minus e to the 0 power is 1. So we get 0 over 0. 0 over 0 is what we call an indeterminate form. Doesn't mean we're done. It doesn't mean it's undefined. Doesn't mean it doesn't exist. It means we have to do more work. If it were algebra, we'd factor and reduce, or rationalize, or multiply by the LCD. But it's a crazy function, so we use L'Hopital's rule. So now we could do the limit as x goes to 0 of f prime of x over g prime of x minus the derivative of e to the 2x, so minus 2e to the 2x. So it's going to be f prime of 0 over g prime of 0 minus 2e to the 0, so it's just a minus 2. And here we go back to part A, f prime of 0 is negative 1 over 12, and also from part A, g prime of 0 being 1/2, so we get negative 1/12 over negative 3 over 2. And you don't have to do all the arithmetic, but you will have a calculator available, so you get 1 over 18. But the key is right here. A lot of people put 0 over 0 and just stopped and said does not exist. It is not a does not exist. It's an indeterminate form, which means we have to keep going and use L'Hopital's. The last part, again, guaranteed a value c on the interval such that f prime of c equals 0. Well, since they tell us that f is differentiable, by mean value theorem, we could do f of 1.5 minus f of 0 over 1.5 minus 0 is going to give us f prime of c. Well, let's see what happens when we sub in. We get 0 over 1.5, which gives us f prime equals, whoops, that should be an f prime of c, not f prime of 0. F prime of c is going to equal 0. So yes, by mean value theorem, there is a value c on that interval such that f prime of c equals 0. And again, mean value theorem, it's been on almost every question I've given you. You've got to get used to thinking that way. Okay.